Okay, thank you.
Okay. So as you are already aware, today we'll be looking at methods and method overloading. So it's just a continuation of what we have done so far. I think the last class was on classes. Method is just it's just under classes. So if you miss that class, I'll do a recap so that we are all on the same page. So we know that we have a lot of primitive data types. By now I'm sure you know of int, string, arrays, and other ones. Now these are data types that are being created in the programming language that you use. There are other data types that we can create, and classes gives us the opportunity to do exactly that. We go to examples that will show you what I mean. Another thing is, if you talk about a class, those who were in class last Friday, what's a class? In programming, when you talk about class, what does it mean? Hello? When you say a class, what is it? Should I call someone? Okay, Andy, can you tell us what a class is, so that those who were not here last Friday will be on the same page as we move on?
Oh, Peter was about to say something. I can see.
That's good. I was looking for someone. Okay. So well, you can unmute and tell us what you remember about classes.
I can see he has unmuted himself, so maybe he's about to say something before I say something. Or should I talk? Should I talk, or he say something?
Yeah.
So last week we said a class is a blueprint of a created object, and we can use a single class to create multiple type of objects. And we made an example of a class being a human. So we have a class of human, but then we can create an object called Amos. You can create an object called Andy. You can create an object called Amankwa. These are all blueprints made from one single class called human. So we all have eyes, nose, legs, and everything, but our names, and there are some other attributes that differentiate us as different unique objects. But then we all fall under the class called object human. So basically, this is what I took from our previous class. A class is a blueprint, or it's like a carbon copy, what we use to create an object. So I hope I've answered the question.
Yeah, I think that's fantastic. The keyword here is blueprint. So a class is, I don't know whether you know what a blueprint is. So before you put up a building, you create this document that details what has to be done, where the kitchen has to be, where the bedroom has to be. Then based on that blueprint, you create the structure. Classes are just like that. So we create a structure of how the class should be. Then we can create a lot of objects or a lot of structures from that same class that we've designed. So the keyword is blueprint. Another thing that you have to remember is instance. So when you create an object from a class, that object becomes an instance of that class, or of that blueprint. Okay, so methods are in so functions that are in classes, we call them methods. So what is a method? So a method is a way to perform some task. So if the class needs to do or perform a particular action, what we do is we put it in a function. Now, in object-oriented programming, when you talk about function, it's the same as method. So I may use the names interchangeably. It's the same thing. So a method performs a particular action or task within that particular class. A method is a block of code which only runs when it's called or used. So within that class or within that object, you could have a lot of things, but methods are only called or are run when you actually make use of them or when you call them. We go back into code to see how that looks like. You can also pass data known as parameters into a method. So when you pass data into a method, that data that is being passed into that method is what you call I need a pencil to write okay, so parameters are data that we pass into objects. Now methods are used to perform certain action, and they are also known as functions. I've also talked about that. Now why should you use methods? Now methods are used to write so we write the code once and use it at many places. So let's say we want a method that actually add two numbers. Now we write this logic of adding these two numbers within a particular block of code. Now we can, when you create an instance of that class, we can use that add method in a lot of places. So in that case, what we do is it becomes easier when you have to modify the method. So let's say if there's an issue that we have to face, we know that okay, adding of numbers is within this particular method. So you go there and face that thing. Now another thing is readability of code. So it makes it easier to read your code. So if you, as I said, if you want a method, if you want where things are being added in your code, you go to the okay. So I think someone's hand is raised. KB, why you can unmute and ask your question before I continue.
All right, good evening.
Yeah, good evening.
Yes, please. You talked about parameters. I'm asking if it's different from arguments.
Yes, they are the same thing. They
All
are the
right,
same.
thank you.
They are the same thing. So it's either argument or parameters. They are all the same things. It's the same thing. So I was saying that it makes it easier to modify code. It makes your code readable. Then it makes reusability of code. So you write once and you're able to use it at other part of your code. Now the method is executed when we call it. I will demonstrate that what we mean by calling it, or the better programming word is invoke. So when you call a method, you are invoking it. So when I say invoke, I mean calling the method. Now there is this special method that is unique to almost all high level program. We call it the main method. So most programming languages have main. Java has it, C Sharp has it. I think these are the two that I can say of. I don't know whether Python has it, but most programming languages have what we call main. Now, main is the starting point of your code. So when the compiler starts to run, where it looks first is the main method. You paste it, then start executing your code. Now, in some programming languages, if this method is not declared, your code won't run. So you should take note of this main method. Now, how does a method looks like? So this diagram shows how a method looks like. So a method has 6 components. We call it the header. Now, I'm sure you've seen this before. Public is called accessor. I will explain it. I think you might have encountered it in the last class. I'll explain what public is. So accessor. So it's like a way to prevent people getting access to the method. So you have public, private, protected, and default. We will talk about them, and most programming languages have this. The next bit is the return type. So the method, after the method has finished running, what should you expect from the method? What data type should you expect from the method? So that is the return type. So in this case, we are calling it int. The next main thing is the method name, the name of the method. So here you are calling it sum, and the another important bit is the parameter list. So that one is in parentheses. You can have a lot of parameters. It can be one. There can be none. So in that case, you have there won't be any parameter within. You can have as many as you want, and that will lead us to a very important concept called method overloading at the end of this lesson. So Andy, please monitor the chat for me, because I'm in slide share mode, so mostly I may not see those asking questions.
Okay, sir.
So if anyone has a question, you can ask. Andy will monitor and let me know. So this is an example of a class having a method called int. So this code can run in most programming languages, but this is Java code. So as you know, the accessor, we have public, and int being the return type, sum being the method name, and the int a and int b being the parameters. So here you have 2 parameters for this method. So I've already talked about this. Okay, so I think you've seen enough of slide. Let me go to the code and just show you an example of what we are talking about, so that before I come back to the accessors. Okay, so this is a sample Java code. I hope you are seeing my screen now. Now, I made mention of the main method. So this is the starting point of your program. You can have a lot of code within a particular class, but the main method is always executed first. That's the starting point of your code. Now, let me show you. I have a class called student. Now, this class has a lot of things going on here. So this is the name of the class. These are variables. These are what you call fields. They are kind of variables within that class. Now, the next bit is the method. So this is an example of a method. Now, as you can see, this method doesn't have any parameter. Now, who can tell me the return type of this method? when you run this code, what is the data type that will be returned from this particular method?
Okay, so it will return an integer.
Okay, please mention them so that next time I'll.
Okay, I'm called Dazi.
Dazi, okay, Dazi. Nice
so yeah, so this will return an ID, which is an integer.
Perfect. So this particular method will return an ID, this one, the ID over here. I'll explain it. I just want to show you how a method looks like. So this is an example of a method. So the return type is an int. That's what Dazi said. So when you run this particular method, the data type that you're going to get is an int. Now, what's the name of this particular method? Another person can.
Cringe.
Yes. What I heard someone speak. What is the method name for this particular method that we have over here?
Get ID.
Yes, the method name is get ID. Perfect. Now, what is the accessor for this particular method called get ID? Is Dominic on? Adam.
So it's public.
Okay, so the accessor for this method is public. So I will explain all these accessors. So I think by now you've seen we have private over here, we have public. I will get back to these accessors. Now let's go and learn what each one of these things mean. Okay, so from where we went, I think you saw a few accessors. Now, what's an accessor? Accessor or specifier is an access type of the method. It specifies the visibility of the method. So, as I said, it's a way of hiding who sees what. Now, if you declare your method as public, now the method is accessible by all classes when we use public specifier in our application. So if you use public, that means that anyone that inherits that particular class or have access to that particular class will have access to the method that has the public accessor. Now, another accessor is private. Now, when we use private accessor, the method is accessible only in the class in which it is defined. So what that means is, if you have a class and you make a method private, now when you go to another class to create an instance of that particular class, all those classes that have private accessor, you won't have access to them. Now, protected, I think you learn more about that one when you start inheritance and polymorphism. Now, what protected means is when you use protected access, the method is accessible within the same package or subclasses in a different package. So, for example, we have what we call inheritance. Now, Andy made mention of that. In classes, you can have a bigger class called animal. Oh no, let me go way down. So you can have living things. Now, you know, living things. A living thing can either be a plant or animal. So plant and animal are kind of children of living things. Do you get it? Now, if you come to plant and animal, we can have human and mammals. So that kind of structure is laid out that you could have the same variables that are unique to all of them. For example, if you are in a human class, you could have a human called Andy. You have another human called Amos. Now, these two objects could belong to the same class, living things. So in that case, let's say that there is a method in living things called eat. Now that method, if it's declared as protected, all the human beings in that particular class could have access to it. Now, another class, non-living thing, or wouldn't have access to that particular method. Probably when you get to your higher level, when you get to polymorphism and inheritance, that one will be clear. Now the last bit, or the last accessor, is default. Now what default means is, if you don't add any, if you don't specify any of these three, public, private, and protected, it's assumed that you are using default, and it's just like public, anyone can access it. Okay, so I think let's go into the code to have a feel of what I mean. So I have here
there's a hand raised. Amankwa.
Yeah, Amankus, you can talk.
All right, cool. My contribution is the last Friday, I think you learned about the classes and also modifiers. So when we say accessors, it's the same as modifiers. So they are not two different things, so it's still the same thing. Whereas we have arguments and parameters. Argument and parameters are still the same thing. And as well as methods and functions are also the same thing. So when we say accessors, it's the same as modifiers. So that's my contribution. Thanks.
Okay, thank you very much. Okay, so let's go back to code and see what we've been talking about so far. Okay, I hope it's bigger enough for you guys to see. Now, I have a class here called calculator. Now, this class has a lot of methods. You have one method called add. There's another method called multiply. Now, let's try and create an instance of the calculator object inside our hello world class. So as you already know, this is how you create an instance from a particular class. So you have calculator. Let's call it calculator with a smaller letter. Is equals to new calculator. So we learned that in our other lesson, that if you want to create an instance of another class, you use the keyword new. So I've created an instance from this calculator method, and this one can have access to all the methods that are here. Now let's use the intelligence to see what you have. When I click on dot, you see you have add, you have a lot of add, you have multiply. Forget about the other methods. These are methods that we get, but concentrate on this add. There's another add over here, and multiply and factorial. Now if you look at this one, we have, let me push this one down small. So you have factorial, multiply, and two add functions. Now all these ones are public. That's why we have access to them here. So if I do multiply, I have access to this method, and I can use it without any issue inside my code, as you can see. Now let's look at what will happen if you make the multiply private. So let's go to our code and change it to private. Now if you make it private, what it means is this method is going to be available only within this class. Now if you come to the hello world and try to do cat.multiply, as you can see, we don't have that particular method, and you're going to get an error, as you can see, because this particular method has been marked as private, and we can't have access to this particular method inside here. Although if you're inside the calculator method, we can have access to the multiply method just like that. and that should be fine. Within the same method, you can have access to it. But if you go outside, within the same class, sorry, you can have access to it. But if you go outside, you have access to classes that have been marked as private. Now I'm going to ask a question. Now let's say I have a student class. Now all these ones are marked as private. Now who can tell me, if you go to the Hello World class and we want to get access to the name variable, will it be possible? Hello? Can someone help
No.
with the answer? No, because it's private. So if you come to the Hello World class, let's try to create an instance of what student, eh? So let's call it
Yes.
Your Dazi. Let's call the student Dazi. It's better you use small letters for names. It's just convention. It doesn't mean anything. Okay. Now, mind you, inside the student class, we have a lot of, we have this face inside, ID, and name. Now, let's see if I can have access to Dazi's name. If I do Dazi.name, as you can see, I don't have access to that particular variable. Now, let's say we have another variable. Let's give that one public. Should be string, and let's call it an email. Now, because it's public, when I come to the Hello World class, I can easily have access to the email. Okay, so this is a little bit about accessors modifiers. So if you have public, anywhere you can have access to it. If you have private, it's only available within that particular class. The protected is kind of inheritance stuff. I'll leave that one out. Probably in the next class you understand that more. Now let's go back to our slide. We'll come back to the code and actually run it and see how method behaves. Okay, so when I'm giving a method name, it's better you name you use unique names for the method, and the method name should just like the name that we give to variables, you should follow that pattern. Now it's very good to use verbs to name methods. So for example, a good method name could be speak, sum, add. All these are method. Now if you have two or more names, for example, if you want to find an area of a circle, so area of a circle, so you, first of all you have find area of circle. Now the first F can be small letter, then the rest becomes a camel case. This doesn't matter based on the programming language that you can have a lot of convention that they follow. Now we have two types of methods when it comes to programming. Now you have predefined method and user-defined method. Now you have seen a lot of user-defined method. I showed you one, the add. We created that method. Now predefined methods are methods that comes with the programming language. So print, system.out.print, sum. There are a lot of methods that are part of the programming languages that are available to the programmer to use. So all these ones are called predefined methods. Those methods are not defined by the programmer. It's part of the programming languages. The user-defined methods are designed or defined by the programmer. Now we have this important thing, static and instance method. Now when you talk about what is a static method, a static method has the keyword static. In other words, a method that belongs to a class rather than an instance of of a class is known as a static method. Now, I think we've stressed this for a long time. Instance of a class. Now, when you talk about instance of a class, when you create an object from a particular blueprint, that becomes an instance of the class. Now, when you talk about static method, now static method belongs to the class, not the instance of a class. What's the difference between that? Now, when you want to use an instance and a static method, you don't need to create an instance of the class to do that. I'll give an example of that one. Whereas when it comes to instance methods, so instance methods are methods that are or belongs to the instance or what the object that has been created from that particular class. Now, let me show you an example so that you understand it better. I have this method, this class here called person. Now, person has two methods over here, say name and say something. Now, if you look at this particular method, this method has a very unique keyword called static. This one doesn't. Now, when a method has what you call static, that means that that method is part of the class, not an instance of that class. I'll show you what I mean. So what it means is that I can use this particular method without creating an instance of this particular class. Now, please pardon me to go back small. I think I forgot to make mention of this particular unique keyword, void. Now, if a method doesn't return anything, we declare or the data type that you use is void. Please take note of that. So as you can see, this method doesn't return anything. That's why the data type is called void. Now, what I was trying to say is if you have a class, you can have an instance method and a static method. A static method has the keyword static and is part of the class rather than instance of the class. So let's go to our hello world and let's create an example of the person class. Okay, so the name, let's have another person. Okay, now mind you, we had two methods within that class. So if I do amos dot say name, now I had to create an instance of the person class before I could have access to say name. So now let me run this particular code. On the console, you should have this say name. Let me clean it up a bit. So you have the say name. Now, static method, I don't need to create an instance of it. I can just do the name of the class dot. As you can see, I have say something. This is a static method. I didn't need to create an instance of the class to have access to it. So let me comment this one out, then run. Then you have here. So these are the difference between static method and instance method. Static method, you don't need to create an instance of the method to use it. But for an instance method, you have to create an instance of the class to have access to that particular method. Okay, I think I have 30 minutes left, so let me go back to the slide so that we can quickly come back to our code. Okay, so you have these are types of instance method. You have setters and getters. Please take note of this. I'll show you in the code. You have abstract method. So abstract methods, these are methods that do not have method body and is known as so a method that do not have body are called abstract method. In other words, the class that is making or extending this particular abstract method has to declare what this method should do. So if you have an abstract method, it's just it doesn't have what to do. So whichever class that is calling has to define what that particular class should do. Now, I think from here, I'll go back to the code. Method overloading and those things are very important, but I think it will be good when I use code to show it. Okay, so let's go back to our calculator class. Now, let's try and do this thing. Let me comment this one out. Now, I have this method that add two numbers. Now, let's go to our hello world class, then create an instance of the calculator class. So let me call it calc. Okay, so I've created an instance of the class. Now, if I want to add two numbers, I just do calc.add. Now, the first parameter can be anything. I think it's important that I go to the method itself. So you've already know how you define a particular method. You should have accessor, the type that is returning, the name, then the inside the parentheses are the parameters or argument of that particular class. So as you can see, the name add, what I'm doing is I'm just whatever the person brings, I'm just adding those two values, then return it to the user. Do you understand? So as you can see, you have 4 and 5. Now let's run. Does it log it? Okay, so let me print it. So in Java, if you want to print something, use system.out.print to print something for you to see. So I'm just going to call it and print it on the console. So this is how you call or invoke a method. So I'm going to run it. As you can see, I have 9 on the console. So if you add 4 and 5, you're going to have 9. Now let's play with bigger numbers. So that's it. So we created this particular add method, and it was able to add two numbers. Now let's create another class called subtract. So public, it will return an int. Let's call it subtract, and you pass it two numbers, an integer. The next one will be another integer. So this is the definition of the method. Now we are just going to return a minus b. So anyone that calls this method is going to subtract the second parameter from the first one. Now let's go to our code, then call subtract. So let's make it easier. 10 minus 5, we all know the answer should be 5. Let's run it. And we have 5 on the console. Now we can have a lot of these method That's the usability part that I was talking about, and it will perform whatever we want. So we have just one code and we are calling it multiple times, and it will work anywhere that you call it. So that is it. We can play along with other values. So this is it. Now what this brings is, let's say now let's go back to our calculate method, the add method. The add method accepts 2 arguments. That's what you've done. Our add method over here takes 2 arguments. Now let's say we change our mind and we want to add 3. Now what you could do is we can come here and add it, and C, then A plus B, A plus B plus C. It could work, but look at it. We have an error over here because here we are only passing 2, but here at this method you have changed it to 3. Now that is where method overloading comes into play. Now what method overloading means is you can have a method that have the same definition, the same return type, the same name, but different number of arguments. Now we don't want to break this code, so what you can do is you can let this one be as it is. We don't want to touch it. As you can see now, hello world is okay. Now what you can do is you can create what we call method overload. You can create another method with the same name but different number of arguments. So C. So the same method, the same add method, we have one that takes 2, we have another one that takes 3. So look at it here, you call add with 2, we are okay. You can also call add that takes 3 parameters, and the code will be fine. As you can see, it's not complaining anymore. Now to show that it's working, let me just log it to show that we are not breaking anything. So this add method takes 3 parameters. Now let's run it. Did I add the last bit? I think I didn't add it. So you have to add the last parameter, C. So as you can see, we just came here to change it at one place, and the code should be running as expected. So when I run this one, you should be getting 10. So this is what you call method overloading, a method that has the same name, the same data type, but different number of parameters. Please, do you understand? If you don't understand, you can raise up your hands and ask your question before I go to the next one. Any question? Yes, Amaka, you can ask your question.
Okay, cool. Mine is also a contribution.
Okay.
At times also it can be the same number of arguments, but then different data types. So it can be the public int add, and into bracket we have the int A and int B, which is okay. And the second one can also be public int add, int A, and let's say double B. So it can be the same number of arguments, but then the data types can change.
Okay, so this is what it means. So they say let me use these two. Because so let me make what is this one will be double, and this one will also be double. Because int is a valid one, so let me change it to string so that the data type becomes different. So you can't really add two Is it concatenate? So the return type should be noun string. So this is an advanced form of method overloading. So as you can see, you have different methods with different data types, but with the same name. So that is method overloading. You can have one method, a method with the same name, but different parameters or different data types. Now the next one is method recursion. Now who can give us a formula for does someone want to? Ellen, do you want to add something? If that someone is talking, let me continue. Now, I was asking a question. Who can tell us the formula for a factorial? So if I say 3 factorial, what does it mean in mathematics? Who can tell us how factorial works? Hello. Okay, Amanga, you can tell us.
Okay, it's just the number multiplying the, let me say the numbers that precedes that particular number. So if it is 3, it will be 3 times 2 times 1.
Yeah. Okay, so this is what it means. If you have 3 factorial, it's the same as 3 times 2 times 1. So as you can see, start from 3, then reduces up to 1. If you have 5 factorial, it's the same as 5 times 4 times 3 times 2 times 1. So this is how factorial works. Now, as you can see, the number keeps on reducing, but it multiplies the least number from the previous one. Now, we can solve this or can write a method that mimic this using what we call method recursion. That when we talk about method recursion, it's a method that calls itself. A method that calls itself is what we call method recursion. So I have an example over here, factorial. Now, 0 factorial is equal to 1. So if the person gives us 0, you return 1. Now, if the person gives us a number that is not 0, what it means is we just multiply the number minus the less number. So as you can see, I've just called the factorial within the factorial method. So what it will do is we pass 2 to it. Okay, 2 is not equal to 0, so it comes here. So it becomes 2, then it passes 2 minus 1, so it becomes 1. Then it calls itself and calls it until it's equal to 0, where it will return 1. Then in that case, the method ends. So when a method calls itself, that is called recursion. Now let's run this factorial and see how it works. So let me call it factorial is equal to calc dot factorial. So let's pass in 5. Now let's print it to the console so that you see what is actually within that particular factorial. Now, so mind you, I said a method recursion is a method that calls itself. So as you saw within the calculator method, the factorial method was calling itself within the same method. So let's run it and see what we get. So 5 factorial, the answer is 20. Now we are printing all this one. That's why we had the 10 over here. But 5 factorial is equals to 120. 5 times 4 is going to be 20 times 3, 60 times 2. That's going to be 120. So that is method recursion. So in all, if you want to recap, what we've learned so far is a class can have a piece of code that does a particular action, and that specific action can be called number of times, and it becomes easier because you can use that same method multiple times and it will have the same result. Now we also learned that a method have what you call accessor that determines who sees what, who can have access to. The method have a data type, what the method will give when you invoke it. The method should have a name. Then a method have parameters. It can be one, it can be two, it can be a lot of parameters. Now if a method, two methods have different parameters, we call that method overloading. You have the same method but different number of parameters. Now if a method calls itself, that is what we call method recursion. So I think that is that for method. I'm going to hand over to Andy. Anyone with question can ask, then I think we can help each other if you have any question. So Andy, over to you.
Thank you, Amos. You've worked within time, and we even have more time. And thanks for your explanation. However, I've seen methods being declared with open arguments being passed. I don't know if you can highlight on that, or maybe that one will be taught in the next class. And also,
I didn't get your question.
So I've seen methods being declared with open argument being passed. It's like, you see right now what we have is like we have set of arguments, 2, 3 sets of arguments. Can there be a method where the user or the intention is that you don't know the number of parameters you'll be passing to the method, but then you've declared the method in a way that it will take that kind of number of arguments whenever it's passed? I don't know if I'm making my point clear.
Yes.
And also,
so
my last one, can there be methods without parameters? Because since all our examples we are creating it with parameters. Yeah. So that's my question.
Okay, so to answer the first one, you can, so I think it's called spread operator. It's in some programming languages. So what you do is, if you don't know the number of parameters that you want, you can just use, there are two ways of doing it. What you can do is you can use an array. So an array can have as many length that you want. That's the most easier way of doing some of these things. So instead of specifying, for example, let's say this add method over here, I can have what you call an array. So let me return something so that the method. So what it means is, in this case, the user is going to give us any number of arrays, then you should be able to return the sum. So what you can do is you use what you call for loop. So for int I is equal to 0 to I is less than the numbers the length. That's where you stop in I plus plus. So what you do is, so let's say you have sum, int sum appears equal to 0. So this one way of doing it. I'll show you the other one also. So what you do is, let me return the sum so that you don't have errors. I hate seeing errors. Now sum is going to be equal to numbers I plus sum. So in this case, you can pass as many as you want parameters to this particular add method, and you should have an answer. So for example, let's say in sum, whatever you want to call it, you call it calc.add, and in this case, you're going to have how do you declare a list of, and the Java gurus over here, how do you declare? So let me have it on top over here. So I think it's going to be new int.
It's curly braces.
Then you specify the length, right?
Yeah, this also works. Yeah.
Okay.
But
so
then you can just do int numbers equals the curly braces. You just pass your values.
Okay.
Yeah.
So
curly braces.
This one.
Yeah.
Then I can pass
yeah.
numbers. Okay, perfect. So this one can take as many arguments that you want, and this should be fine. As you can see. Okay, thank you very much, Marvin. So as you can see, we can have as many parameters as we want. Let me run it, and this should be fine. That's it. That's our sum. So we have a lot of parameters over here. So this is a way of having a lot numbers, a lot of parameters within a particular method. The next one is what you call the spread operator. So in that case, you do int, then dot dot dot. So let me call it the argument. How is that one done?
Just make sure there's no space between the ints and the dot dots. And not, yeah, just bring your space. Yeah.
Yeah, like this.
Yeah. So you can start using.
So in this case, you have to know that, okay, the ask is going to be an array, the first one, then the next one. So this is another way of having as many parameters you want within a particular. I think it's the same definition as this one. That's why it's complaining. So let me comment it, and this one should be fine. So if you do this, in that case, you can have as many you can pass as many parameters to that particular method. So in that case, you can have the sum 1, 2, 3, whatever number that you want to have.
Yes, the same. Sorry for cutting, but you can even pass the same numbers. I think it will work.
Okay, the same arrays to it, and it should be fine. Yes, exactly. Yes, so that is one way of passing any arbitrary number of argument to a particular method. Now the next one, you said, can a method have 0 parameters? Yes. If you look at, I think I had one. Yes, this one, this method, say name. It doesn't have any parameter, but when you run it, you are going to get something from it because we are just printing whatever is within the name variable. So a method can have 0 or more parameters. Andy.
Yeah, thank you very much, sir. On this note, the floor is still open for any questions. Today we are within time, so our tutors too are here. I'll open the floor for them to add or give their comments so far, what they've seen, and maybe if there's anything they want to add. So the floor is open. questions and contributions, both from our teachers and students. Mr. Mankwa, do you have anything to?
Okay, cool. I think the first thing that I would like to stress on is Amos made mention of instances of class. When we say an instance of a class, it's just like you creating a copy of that particular class. So let us use the person, for instance. A person is a class or an entity on its own, and you just want to get a copy of it and use it somewhere else. So that's how come we use the keyword new to create a new copy of that particular class. And that particular class, you don't touch it. You're just creating a copy of it and just use it. It doesn't mean that you're going to alter the actual class. So that's how come we use the name or the keyword instance. So if you want to create an instance of that class, you have to use the keyword new to create that instance. So you're just going to use to create a copy of that class. So that's the meaning of an instance. And also, as he also said, with the modifiers or accessors, we have different types of modifiers. We have the public, the private, the protected, and if you don't specify anything, the computer takes it as the default one and normally operates as the public one. So if you don't specify anything, so for instance, the say name, you can get rid of the public and just leave it as void say name. I think Amos didn't demonstrate that particular part. You can just get rid of the public and just leave it as void say name. And this thing is going to still work as a public method, which can also be accessed. So when you take those things, you can just say someone, let's say Amos has his own car, and his car, he uses it privately, and no one has access to that particular car. But then he can buy a bicycle and say, okay, fine, this bicycle is a public bicycle, and anyone can have access to that particular bicycle and make use of it. And now I can say, okay, fine, I have my TV, and this TV is going to be used by myself and all my descendants, those who are going to inherit my things or my properties. Those are the only people who are going to use this one. And that's how come we use the protected. So it's not going to be used by any other person who is not from the family. Only those who are in the family and they have some things in common. That's where we use the protected. But then if I use public, it means it can be used by my family and any other person who is not in the family. If I use private, it can only be used by me. It cannot be used by, if I use private, it can only be used by me. It cannot be used by any other person from the family or any other person from the public domain. So those are the differences, the public, the private, and also the protected. Thank you.
Yeah, thank you, sir. I think this particular side of the topic will be more highlighted in our next session on inheritance and all that. So I'm urging all of us not to miss our next class for the end of the month. I think that's our last class for the end of the month. So let's make it a point to come for the last class for the end of the month, and we'll share all the information for the next month, February, on our various platforms, our WhatsApp page where we share our information on everything that we do. We also appreciate your time and efforts for joining today's meeting. On that note, if there's nothing to add, especially my tutors, I can see Mr. Arthur here. I can also see Mr. Edu. If you don't have anything to add, on that note, I'm calling the class to an end. So see you next week, this week Friday, sorry. See you this week Friday for our next session. Thank you very much. Bye-bye.